We are now looking at finding solutions of simultaneous linear equations. Now, we have talked about this, I know that. And what you're basically doing is we're going to use the graph. So we are actually talking about doing it graphically at the moment. And these are the 4 steps you need to do. So what we're talking about when graphs are solved simultaneously, it's where they intersect. We're looking for the point of intersection. That is the point at which both lines exist. Now, they can have both, like I did, a positive and a negative gradient, but you can have 2 positive gradients and they will still intersect. Every pair of lines that are not parallel will intersect once and once only. So when we solve them, we will find the one point where they both exist. Now, this is another situation where you're learning this concept and you're getting just arbitrary equations that have no meaning at all. Later on, we'll use it to find things like best value or break-even point, and it'll make a bit more sense in context. But at the moment, these are just arbitrary equations and we're just going to plot them. So for this first one, I'm going to do in red. I know that my gradient is 1 and my y-intercept is 3. Now, I'm doing that relatively quickly because you guys, we have done this and you should be fine with it. So my y-intercept is 3, so I'm going through there, and my gradient is 1, which means my rise is 1, and my run is 1, which means that's another point on it. So I can now draw that line with a ruler down, and that's my line. The other one, I have a gradient of -2 and a y-intercept of 0. There is nothing at the end there. Okay, so I go over and go, well, my y-intercept when x equals 0, y equals 0, so that's my y-intercept, and my gradient is -2, so that means my run is 1, and I go down 2, so my rise is -2, so I'm down there. So I'm now going to draw that line in, and it looks a lot like that. So now what we're trying to do is find where do those 2 graphs intersect. So I have a look at that point there, and they intersect at point. So I'm actually going to call it simultaneous solution when x equals -1, because I'm reading this point here, -1, and y equals 2. So I would normally write that as an ordered pair or a coordinate. And so that is -1, 2. That is the point at which they intersect. So that is the point of intersection. So you'll see it written as point of intersection, or sometimes we'll refer to it as a solution, a simultaneous solution. Alrighty, done.